Hi. So right now I am going to discuss about problems applying the four conditions of rectilinear translations. I'm going to use the following notations: s equals distance, x equals horizontal displacement, equals vertical displacement, v equals velocity or final velocity, v sub 0 is equal to initial velocity or velocity at time 0, a acceleration, g is acceleration due to gravity, which is equal to 9.81 meter per second squared or 32.2 feet per second squared, t for time. For our first problem, we have a car travels along a straight road at a constant 72 km per hour. Determine the car's distance after 2 minutes and 5 minutes. So we are going to use constant velocity formula, which is equal to s is equal to velocity times time. Our given is v is equal to, or velocity is equal to 72 km per hour, and we're going to convert it into meter per second. So multiply by 1000 meter over 1 kilometer times 1 hour over 3,600 seconds. So the answer will be 72,000 meter over 3,600 seconds, which is equal to 20 meter per second. So for the time, we have 5 minutes multiplied by 60 seconds to convert it into seconds is equal to 300 seconds. So substitute to our formula, we have velocity is equal to 20 and time is equal to 300. So 20 times 300 is equal to 6,000 meter. So this is our final answer. Next problem, we have determined the velocity of progress with the given equation d is equal to 20t plus 5 over t plus 1 when t is equal to 4 seconds. And so we're going to use variable acceleration formula, which is equal to v is equal to ds over dt. Given that d is equal to 20t plus 5 over t plus 1 and t is equal to 4 seconds. So v is equal to d big letter d over dt equals 20t plus 5 over t plus 1. So derive that, which is equal to 20 minus 5 over t plus 1 squared. So when t is equal to 4, substitute 4, we have, using the calculator, 20 minus 5 over 4 plus 1 raised to 2 is equal to 19.8 meter per second. This is our final answer. For our third problem, we have, with a starting speed of 30 km per hour at point A, a car accelerates uniformly. After 18 minutes, it reaches point B 21 km from A. Find the acceleration of the car in meter per second squared. So we will going to use constant acceleration formula, which is equal to s, or the distance is equal to initial velocity times time plus 1/2 a time squared. We have given the initial velocity, which is equal to 30 km per hour, and to substitute it, multiply by 1000 meter over 1 kilometer times 1 hour over 3,600 seconds. So the answer will be, using the calculator, we will have calculator, and here the answer will be 8.33. Next is the time. We have to convert time also, which is 18 minutes times 60 seconds over 1 minute is equal to 1080 seconds. Next, for the distance, we have given 21 kilometer. We were going to convert it also, and we have 21,000 meter. Substituting for our formula, we have initial velocity times time plus 1/2 80 squared, which is equal to 8.33 multiplied by t, which is 1080 seconds plus 1/2, and of course we're going to substitute s also 21,000. So the value of our a will be, using the calculator of course, so we have 0.0206 to round off. meter per second squared. So this is our final answer for acceleration. Problem is, a mango falls from a branch 5 meters above the ground. With what speed in meters per second will it strike the ground? Assume that g is equal to 10 meter per second or ground up lang ang 9.8. So, and of course, we're going to use free falling formula, which is v squared is equal to initial velocity squared plus 2gh, or the acceleration due to gravity and height. We are given initial velocity of 0, of course, because it is free falling. Then for our height is 5 meters. Substitute for a given formula, we will have 0 squared plus 2 times 10 times 5. So the answer will be velocity is equal to, using the calculator, it's 100. Getting the square root, we will have the final answer, which is 10 meter per second. So this is a clear screenshot for my solutions. Thank you so much and God bless. Bye bye.